Hey math kids, today we're going to talk about the gradient of a tangent. So if the limit exists, the gradient of a tangent to a curve at a point is, so let's draw a diagram. So if we want to find the gradient of that tangent at point A, then we just need to do the limit as h approaches 0 of f of a plus h minus f of a over h. Now this may feel like a different equation or different formula than what we've been using, but it's actually the same idea. So let me just kind of explain this. So I'll try to draw a similar thing to that. Now if we're thinking average rate of change, let's say, let's do what letters? Let's do B and C. I want to stay away from that A. Okay, so if we're doing average rate of change, now maybe I will. Yeah, let's do A so it lines up better. Okay, so I'm going to call this A, and I'm going to call this B. No, I'm not. I'm going to call this distance h. And so this point would be A plus h. So this f, or this y value is going to be f of A plus h. And this is going to be f of A. Now if we just do our gradient formula, we're just going to get f of A plus h minus f of A over A plus h minus A. Okay, but if we see that, these two are going to cancel. All right, so we have this thing. Now where does this come in? That comes in when this distance h becomes infinitely small. So as the limit of h approaches 0, that just means as that distance becomes infinitely small, then we think of it as an instantaneous rate of change and the tangent at a single point. So anyway, that's where that formula comes in, or how it's derived, where it comes from. If you need additional help, please come to Math Lab. Until then, calculate it.